I would like to introduce our first speaker. This is Eric of Wetzels from Denver, Colorado in the USA, from Carollo Engineers. Eric.
Thank you, Anne-Marie. Well, my name is Eric Wetzel, and I work for Carollo Engineers located in Denver, Colorado. And today we're going to talk about the Part 85 South Secondary Improvements Project. Now, this presentation is probably going to vary or differ a little bit from most that you see today because I'm not going to focus on the 3D model. We took our 3D model and we took it to the next level. We utilized a 4D visualization for help during the construction phase of the project. But before I get into the 4D, I want to talk just briefly about what the South Secondary Improvements Project was. Then I'll get into what is 4D. If you don't know, you're probably already lost in this presentation, but I'll get you back. We'll talk about how we built the 4D model. I'll show you one of the 4D visualizations that we use. I'll wrap it all. I'll talk about the benefits, wrap it all up with a bow, and I'll take any questions that you may have at the end of the presentation. The South Secondary Improvements Project is located in Denver, Colorado, at the Metro Wastewater Reclamation District's Robert W. Height Treatment Facility. We just call it the district, so we don't have to say all those letters anymore. It services about 1.7 million people in the Denver area. South Secondary Improvements Project itself is a $136 million project with the potential for $1.8 million to the contractor for an early bonus, $10,000 a day, up to 180 days early, $1.8 million. The purpose of the project is sort of twofold. First, it is going to meet new wastewater discharge criteria set forth by the Colorado Department of Public Health and Environment. And with that new nutrient limits, it's also going to add capacity to the plant. A brief run view of what we're looking at here. The South Aeration Complex is an entirely new facility. It's about 85,000 cubic yards to build out this entire facility. We're going to be talking about this structure in particular quite often. This is the blower building, but just as a reference point. These are existing structures. This existing structure in the middle is an existing high-purity oxygen system. We're transforming that and modifying it to be a RAS-WAS pump station, as well as a Stage 5. The clarifiers that you see, we're modifying those clarifiers as well with new mechanisms. We're doing modifications to the DAF and Centrate building and building a new ammonia facility. Again, new facility, and then existing facilities. So rehab and new construction across the board. I can't stress enough how very tight this schedule is. With the new permit, we also have a compliance schedule that we need to meet. And based on all the modifications and all the construction, we were up against the wall as far as getting this thing designed, getting it built, and getting it commissioned. It was because of this tight schedule that we decided that utilizing 4D visualization was probably going to be a really strong tool. It's something that we could utilize during the construction phase to really make sure that we were on task and on time. My company's role during the project is we are the design engineer as well as the owner's representative during construction. With that owner's representation, we are tasked to review the construction schedule and verify compliance with the contract. On top of that, we're also responsible for the 3D models and the 4D models throughout construction and beyond. So what is 4D? 4D in its simplest form is taking the 3D CAD model and adding the element of time, the fourth dimension. So the 4D model at that point allows you to visualize anywhere from notice to proceed to final completion and see the planned construction sequence beyond. And if there are any engineers in the audience, I didn't want to leave you out, so I put a formula at the bottom of the presentation. So how did we build the Part 85 4D model? Well, first, before you go to the fourth dimension, you need a third dimension. So we had our 3D model that we did during the design phase. This is a traditional design, bid, build, so this wasn't a design build. This is design, bid, and build. We utilized a number of the Bentley suite to build the 3D model. We ended up with 65 total models. Anything above 2-inch pipe got modeled, and we brought them all into one sort of model space. 99 reference files. It was completed during the design phase, and because I'm not going to focus real heavily on this 3D model, if you're interested in the 3D model, it was a finalist last year, so you could probably just go to Bentley's website and find out more about this 3D model. An important thing to know about the 3D model before you start trying to utilize this in the 4D is that the 3D model must be designed in constructible elements. And what I mean by that is you have to have construction joints, you have to have pipe joints, and those must be exactly how the contractor intends to build it. If you have 200 slabs in a building, your model better reflect those 200 slabs. So the depth of the construction schedule and the depth of the model have to be the same. So at this point we have our 3D model, and it has all the construction joints in it and pipe joints, and it's mimicking what the contractor's intent is. So now we need the schedule portion. We do this in a software called Primavera P6. Any of you in the construction industry, this is pretty standard for large projects. It's extremely detailed schedule, 12,143 activities. Just as sort of a graphical view, the document with the 6S on it is a half-size copy of my structural drawings. Now again, you have 80,000 cubic yards of concrete, so you can imagine what a structural document would look like. And then to the other document on the other side of it is an 11 by 17 printout of the contractor's construction schedule. Both these documents sit about 1.5 inches off the table, so we're talking about a lot of activities to review. So we have the schedule, we have the model. Now it's time to bring those two elements together. And the way we do that is we import the acceptable schedule to Navigator V8i from Primavera, and it's time to physically link this model to that schedule. So in Navigator, here's what you have. You have the 3D model information, you have the schedule information here at the bottom. Now to physically link, it's a drop and drag system. So these are all transformers. If I want to take this transformer and I pull it down to its applicable activity in the schedule and drop it. And some activities have 4 activities, some have 6, some have 8. And so this all, you do this, for this schedule we had about 10,000 linkable activities that we had to go through and link these together. After you link up all the item sets in the model to the activities in the schedule, you close out Navigator V8i and open in MicroStation. And we do this because MicroStation has Animation Producer. And Animation Producer allows us to set time frames and duration, saying I want it from this time to this time, and I want each frame to be a day, or I want each frame to be a month, or I want each frame to be a year. And we can set those standards for what we want to look at in our 4D. After we've developed all the frames, we import it into any AVI making software. We use Camtasia to produce the AVI files. An important thing to note when you're watching the 4D visualization, every start activity, the item will pop into the model space, and it will be sort of a dull green color. As it goes through its cycle, for instance, a slab has 4 activities in the schedule. It has a rebar, it has a form, it has a pour, and then it uses its cure cycle. When you see that, it will pop into the model in sort of this dull green. After it gets through its 4 activities, it will go back to its original design color. So in this model, we're talking about these yellow slabs. They go back to the yellow design color that they were built in. So at this point, I want to show you one of our 4D visualizations. And I'm going to very smoothly transition over to this Windows Media Player file. So what we're looking at is that Southwest blower building. Now we're looking at it. Right here, right here in the foreground, the caissons just went in. A couple things I want you to realize when you're looking at this file is the detail that comes in on this file. Although all you're seeing is caissons and slabs right now, if you look to the left, you'll see a control building. Control building will start bringing in meters, piping, louvers, doors. If you look beyond the blower building, you'll start seeing in the aeration basins a lot of instrumentation come in. And what this is doing is you see the time clicking over here. This is an exact replica of when the contractor intends to build it. So what we have to do for this file is anybody who's worked in a 3D model, which I assume are most people in this room, we have to set transparencies, we have to set speed, we have to do all that so we can actually view what we're doing here. That's a large CMU facade, so once that goes away, we'll be able to see the blowers and beyond. You're seeing the crane come in, you're seeing all the little instrumentation come in. You're basically seeing every piece of instrumentation or piping or HVAC, anything above 2 inches is now coming in. And we did this for the entire site. This is just one structure that I'm showing you because you can see the detail. So if we look, these are small little instruments. These are drop legs for air piping. There's another instrument up here. These are gates. Just the extreme detail that this 4D visualization takes into account. Now smoothly transition back. Okay. So that was cool, but what really did that do for us? How did we make anything of what we just saw in that AVI file? Well, I'm glad you asked. The 4D's benefits are really a tool for risk mitigation. When we linked the whole thing, we were able to push play and validate that the contractor's realistic ability to obtain that full bonus, to obtain the contractual scheduled time. And also, it allows a detailed review and identification of issues that we may have in the schedule. Now, I know you're kind of sitting there going, how do you make any sense of a detailed review of that AVI file? Well, it does a number of things for us. The first example I have is concrete pour sequence compliance. Now remember, when an item comes into the model, it's going to be dull green. When it's finished its process, it's blue. So right off the bat, this is the blower building. This is an older version, and I changed the background color so you can see it better. But what we have here is real simple. We have a wall being poured on top of a slab that's not completed yet. So we can't do that, obviously. The slab needs to be cured out before we can build a wall on top of it. So right here, we have the potential for a 14-day calendar bust. And what I mean by that is, for instance, if this slab and this wall is on the critical path of our schedule, and we have to push that wall now because that slab is not completed, it could be 14 days in our schedule, which is a lot of time in a large schedule. The second bust we have is we're building a wall on top of a slab that's not there yet. This is a simple logic loop in the schedule. This happens often. But keep in mind, whatever we can see very easily visual is a lot of tracking through a P6 file and looking through hundreds of activities to try and find where these links are made in logic. Second thing we can do is missing activity links or inappropriate logic. The software allows us, after everything is linked in the item to the schedule, to shut everything off. Anything that has a link will disappear. And what you're left with is just a number of random pieces all over the place. So you identify those pieces, you find out what they are, where they go, and find out if maybe they just haven't been placed in your schedule correctly, or if that was just missed in the linking. These are two examples, and this is also from our review of the contractor not having items in the schedule. These two walls here, the construction joints were updated. This happens all the time. It's a very common practice to update the CJs if they want to make larger pours, add rebar, things like that. The problem is they updated the construction joints that were acceptable, but they didn't add it in the schedule. So the only way we found this out is because when we ran the model, we said, oh, we've got two walls hanging out here that aren't linked to anything. Mr. Contractor, please add these to the schedule. And they did, and this has been fixed. But again, if these were critical path items, they're not in the schedule at all. That's 14 extra days to cure these walls out. Second example I have on here is a threshold between two facilities. If anybody here has ever built a large schedule, you'll know that it's not just a guy sitting in a room for 3 months building this thing by himself. It's just teams of people. So the people building this facility said, oh, the guys over here will pick it up. People building this facility said, the guys over here will pick it up. Well, no one picked it up. We found that out real easily. And then, but think about the work that it takes to build a little turn-down curb and then the columns on top. You're talking about potentially 28 days there. So we're talking about a lot of time in just a simple image that we probably wouldn't have picked up on until we got to there in the schedule. Probably the easiest way of identifying where they are in the schedule is visual assessment of actual versus planned. This was an aerial photo taken on October 2nd. We get aerial photos every month. This is the 4D visualization of the contractor's intended schedule on October 2nd, and all we got to do is compare the two. There's the blower building that we saw. Well, I can see a couple pads down there, so it looks like the contractor is a little bit further ahead in their blower building than they anticipated to be in the schedule. This will get updated, we'll move forward, and then we can review the rest of the site the same way. A couple of other benefits that I don't necessarily have images for. Every quarter, we update the model based on change orders, field orders, any adjustments in the schedule. So quarterly, we update the model. The schedule gets updated every month. So at the end of this project, the owner is going to have a 3D model that's totally incorporated to all the change orders, all the field orders, and the exact time frame when this plant was being built. Something we didn't anticipate, and it's actually worked out great, is the public outreach. The public is able to see these visualizations. A board of directors, I've never been in a board of directors meetings where they said, I'd like to see the 12,143 activity schedule. They're not interested in that, but they do like to know what's going on, where they are in the project. So this allows us to easily show them in about 5 minutes the anticipated schedule for the project. Identification of nonconformance with contract. it's real easy. We have milestones. We have items that need to start after certain items finish. And visually, I can see that in an instant, whereas trying to follow that in logic loops through a P6 file would be much more complicated, and you probably wouldn't pick up nearly as many issues. And the ability to plan ahead and look for future work. This is an active plant site, so we cannot just shut down the plant. There's no such thing as a plant shutdown. 1.7 million people in Denver would be very upset with us if we shut down the plant. So we need to be able to look ahead and say, operations, we're going to be in this area in January 2013. You know, is there anything that we need to take in consideration there? So we have the ability to look ahead. So that's sort of a summary. It's a 4D tool that mitigates risk of complex and accelerated schedule. This is a very complex facility. It's an existing facility. It has existing pieces. It has 300 people on site every day, including the workers for the construction activities. It helps us minimize the logic loops, missing activities, nonconformance, and it does that by accounting and saving significant time in the schedule. Although I can't really quantify for you the dollars we've saved in using this, it is estimated that we've saved about 60 days just identifying items that were logic loops or issues within the schedule before, sometimes years before they happen. Being able to do that, being able to say, listen, this is an issue. It doesn't happen for a year and a half, but let's table it and sit on it and see what we can do moving forward. It's a huge benefit to the project. It's a tool that engages stakeholders that aren't necessarily involved day to day. Like I said, public outreach, the board of directors. They want to know what's going on, but they can't come on site or they can't be part of the schedule reviews. It's an updated 3D model for facility maintenance and for the owner at a later date if they want to build onto the plant. They can find where all the underdrain is. Even if it was in a change order, they can tie into this project easily. And the versatility of the Bentley software allowed us to use the 3D, the same things we did, the same software we used for the 3D model and utilize in the 4D. We didn't have any additional cost in software or hardware to produce the 4D visualizations in the models. We were able to use everything that we had in the 3D design. So I'll be happy to take any questions if you have any. Yes?
How did you said at one point you had a crane in there. How did you model all of the things that weren't actually part of the project, like the services and the other things?
Well, and I misspoke. It's a roof crane, so it is part of the project. It's for lifting pumps in and out. So we could have utilized that for like construction services, but we chose not to. We wanted to stick with the model that was more or less for the owner and for our reviews.
Would that be a next step then?
Yeah, I think if the contractor wanted to take more of a role in the model, they could say, we want to use resource utilization on your model. It would be quite an effort to get there, but it certainly could be done.
Oh.
Thank you. Thanks, Eric. That was a really good presentation. Excellent. I have a question for you. You mentioned that Carollo were finalists last year with the 3D modelling side, and I know for Carollo you're very, very experienced in the 3D modelling and the ProjectWise side of things. With the 4D and integrating it with Primavera, is this something new for Carollo?
Absolutely. Taking this 4D and doing it to this scale where we're linking 10,000 activities was definitely a new on-taking for us. Primavera is an Oracle software and Bentley they're different entities. And being able to sort of import and export out a schedule like that is something we had never tried before. And it's pretty straightforward actually if you can export the Primavera file as an XCL file, or I'm sorry, an XLS file. You can easily kind of make these two software talk to each other and get it to produce that. Any other questions? Yes?
Impressive presentation. But the question is, so what have you learned? If you say the initial 3D model and the final 3D model, has something changed in that?
I'm sorry. What,
you made the complete 3D modeling at the beginning, and then you make this time progress, and the final model was it different from the beginning of the model?
Well, I think when we started the 4D visualization, there was certainly a learning curve there, what we were going to try and achieve. And so we had to modify our 3D model to build out the 4D. We had to do some of those things I talked about. We're adding CJs and breaking pipe. You know, when you're modeling a pipe, it might be 600 yards long. Well, the contractor would laugh at you if you say you're going to crane in 600-yard pipe. And the answer is no, it's going to join it out. So as far as when we got into the 4D, yes, the 3D model ended up being slightly different because we needed to incorporate the things that how the contractor was going to build it. And it wasn't necessarily a full effort when we were in design. So we had to go modify beyond that.
And it makes it sense to use laser scanning technologies?
Yes, and we've utilized laser scanning technologies on the north end of this plant. It's certainly a great tool after everything's built. But we are talking about a lot of new construction here that we weren't able to utilize that, so we had to kind of take our 3D model and modify it at that point because we wanted to use this tool. This project's still going on. We're about 600 days into a 1,500-day project, so at the end we will probably laser scan just to make sure, because there'll be conduit runs that weren't modeled, things like that. We do have cable tray and all that, but there are still smaller bore piping that's not in the model itself, so we will utilize laser scanning.
Hi. You said the schedule was very tight, and I would imagine just the planning of trying to get everything into P6 and linking it to the Bentley model, the 3D model, it would take time. What was the driver? How did you make that decision? What made you decide to actually do this 4D, when you don't have the time?
Well, we made the decision during the design phase. Carollo put together a critical path schedule saying, what are the critical items, how are we going to get from notice to proceed to final completion, and what's going to be our route? And when we did that, we said, holy moly, we can't miss many days here. And with that, we said, well, the best way to validate a contractor's schedule is to use a 4D tool like this. The contractor is going to submit you a schedule that looks like this. It would take you a year to do an entire evaluation. Now, we do review the schedule, and it took 4 reviews, I think, to get an acceptable baseline. But with that baseline, we I do the schedule review every month. I still have 50, 60 comments a month just because we're still working through it. But we knew that this schedule was going to be difficult. It was complex. It was hard. Everybody in here, I assume, is in wastewater, so you know that these galleries are full of small bore piping, full of couplings, full of elbows, things like that all need to be in the schedule. And there's really only one way to validate that, and that's to go through every item. And we do that by linking to the model sets and then watching these videos to see if we can find conflicts.
What was the time added to the design because of this?
It took, from the time we had done the 3D model, which was all the design phase, that took, I think, a year and a half or something that way. Then the contractor started submitting schedules. When the contractor starts submitting schedules, we start linking. By the time they were done, by the time they had an acceptable schedule, it took us another 6 weeks to fully link the schedule to the model. Now, with those quarterly updates, we've written script to where we don't have to do that over and over again. All we have to do is re-import the new schedule and then link only change order, field order, RFI activities that weren't necessarily in the original baseline.
Quick question. Will your client be utilizing the models in the raw format as a turnover, or are you going to have to export to some other type of format?
No, they are going to utilize this. In the original contract, it was we want to be able to utilize the model. So we knew we were going to go into this having to update the model, but they will be able to use microstation files.
Yeah, question on that utilization. Can the 4D technology be extended over to where, as they begin now to operate the facility, they can go back and link to doing major turnarounds and things of that nature and use the same technology where they can look at scheduling and things related to that?
Absolutely. You can really 4D anything as long as it's an item set in the model and an activity in a schedule or in any schedule. You could certainly use this however you wanted to as far as operations after turnover.
Curious, were you doing interim as-built surveying to update the model, or were you kind of checking things off visually as they were completed, or what?
Well, we do. We have a cost-loaded and resource-loaded schedule. So as things are completed, they get actualized in the schedule. And what that does is it actualizes it in the model, too. So that exact date it finishes will be the exact date in the schedule. As far as
field measurements, or
yard piping and all that goes, it was if we do have record drawing changes, if a contractor lays a pipe and it doesn't end up in the exact location where it was in the design documents, we do update that. We do reflect that in the model when we do our quarterly updates. So the survey data does get back to us, and we do add that to the model.
So did your surveyors have like their own schedule for going around and checking on things?
No. So although we are field inspection, we are not the contractor. So we rely on their survey information that they send to us to utilize to update the model. Any other questions? Great. Thank you.